So hello everyone. In the last session, we have seen about the capacitor, and we have seen the different how to solve some uh, uh, questions on the capacitor like heat loss, and also we have seen the that how the capacitor is actually getting charged. What is the theory behind it, and we have see this thing in very detail. We have solved some questions also, and we have also understand whenever the capacitor is getting charged, there is some heat is going to be lost, and I have given you the some homework on also this. So let us discuss the homework first. I hope this is the one homework which I have given. So what you have to do, you have to calculate the heat loss. The steps are very simple. What you have to basically do, initially if you calculate the initial heat loss will be what? Here there is a no battery is there, so obviously the work done by the battery will be zero. There is a no work done by the battery. So what is the initial energy? If I will calculate, so I will write it as half. What is the capacitance? That is 14, sorry, 1 microfarad, not 14, 1 microfarad into what is the voltage? Half CV square. Sorry, I'm writing wrong. uh, Half CV square plus half into what is the capacitance? That is 1 micro, again it is a 1 microfarad into 7 square. So that is the initial energy you will get. Now what is the final energy? For final energy you have to find the final potential. One concept is that you have to do the same thing which I have told you. So suppose let the charge q flow from this surface. So what is the charge on this surface? It will be 7 plus q, correct? Yes or no? And this will be minus 7 minus q, correct? This will be how much? Plus 10, sorry, minus 10 plus q, and this will be how much on this surface? Plus 10 minus q, correct? So what is the KVL? If you apply, you will get my V1 should be equal to V2. So from that you will get a q 10 minus q divided by how much is the potential capacitance, because V is equal to what? Q by C. So what is the capacitance? That is 1 is equal to what is this value? That is 7 by q, 7 plus q divided by 1. So from here if you calculate 2q is equal to 17. So what is q? Q value you will get from here is how much? That is, oh sorry, that is 8.5 microcoulomb. So this is the q you will get. Once you will get q, you can calculate the final energy, correct? You can calculate the final energy, yes or no? You can do this calculation. You can calculate E final from here. What is E final? Half q square by C, correct? What is q square? See, 10 is there. 10 minus 8.5. 10 minus 8 is 2. 2 minus 0.5 is 1.5. So 1.5 microcoulomb whole square divided by 1 microfarad plus half into how much charge will be on this surface? 7 plus 8.5, that is 15.5. Okay, so that will be 15.5 whole square divided by 1 microfarad. So from there you will get final energy. You have initial energy, so just subtract E final minus E initial, that will be heat loss. So that is the homework which I have given. Next question I have given is the challenge question, and I have given you the time. Oh, like you have to comment this question in the comment section, and then I will take the name of that student who has given the correct answer, correct? So that is, yeah, this is a challenge question for you. Okay, clear? Okay, so let us proceed the thing. In the last class I have told you that you just revise all the circuit theory which we have done in current and electricity, because we are going to use that thing in the capacitance also. We are not going to read everything about whatever we have completed here in that current and electricity, because otherwise there is no meaning of reading the two things, reading the same thing multiple times. Okay, just we are going to see the next topic is circuit theory. Now in circuit theory, in capacitor, what we are going to do, we are going to discuss about the important thing which are different from the circuit theory we have discussed in current and electricity. That is thing we will discuss, and rest of the thing are same. So before starting the discussion, I am making a very important disclaimer which you have to remember. In this topic Okay, in this topic we will discuss only those things which are different from circuit theory in current and electricity. We are going to discuss that much only. Clear? Because that is only the difference. Other thing is same. Why I am saying this? Because rest of the things are exactly same. Clear? So let us discuss some exam. Let us discuss. So the first topic in this is which we have to understand. If you remember, in current and electricity, I have started with the calculation of current in every branch or potential at every branch. How? By taking the potential at one point equal to 0, and then what we do, then we used to calculate the potential at other point, and if we are not able to do, then we assume the potential at some point x, and then we apply the KCL. That we have covered as a separate topic, how to solve a circuit by using a KCL. So here also the everything is same. For example, suppose I give you some circuit like this. Suppose I give you some circuit. Suppose this is 10 volt. Clear? Suppose this is 10 volt. Okay, there is a capacitance. This is 12 volt. Suppose this capacitance is 1 farad. I'm writing in farad. Okay. Suppose this is again a battery of 10 volt, and this is a capacitance of 2 farad. See, what can I ask you? I ask you to calculate the potential or the current, or current not, because here we won't ask current, here we ask charge. Just replace what you have to do. You have to replace, see, potential in current and electricity. What you have to learn, I'm drawing basically a graph, basically not a graph, a type of table which make you things easy. Like whatever the things you have covered in current and electricity, or you can better to write current and chapter 2, whatever the things you are covered in. See, this is our previous chapter is chapter 2, this chapter is capacitor. Okay, in capacitor I'm writing at cap means capacitor, that is our chapter 3. So here we have learned about potential, correct? V, or you can say potential. This potential will be remain potential here. There we have learned about something called as a current. Here it is replaced by Q, means charge. And there we have learned about something called resistance. That resistance will be replaced by here 1 by C. Okay, that resistance will be replaced by here 1 by C. That is the only thing you have to. It is a type of analogy. It is a type of analogy which you have to remember here. It is a type of analogy. Now let us see here how I will solve. Simply, what is my method? What is the method I told you? Simple, you start first assume 0 at some point. Okay, so let us take 0 at this point. If this is 0, this will be 0, this will be 0, this will be 10, this will be 10, this will be 10. What is this potential? This will be 20. What is this potential? This is 0, and this will be minus 12. Can you tell me what is the current flow in this branch? Higher to lower? Sorry, current not charge. So what is the charge flow? Charge flow will be defined as Q is equal to CV. C, what is C? 1 farad. What is the potential difference? 10 plus 12. 10 plus 12 is how much? 10 plus 12 is how much? That is 22. So this, from here the charge flow is 22 coulomb from this current, from this branch. Similarly, from this branch, what is the charge flow? If you see, this is 20, this is 0, correct? So what is the charge flow? 20 into 2, that is 40. So 40 coulomb charge flow from this branch. So 22 here, 40 here. So by KCL, as by KCL is valid for the because KCL is derived from the charge conservation only. So that means if it is valid for the current, it will be also valid for the charge. Why? Because there is an analogy. Okay. So whatever the rules you have learned about charge, that is the same rule will be valid for current. The same rule will be valid for charge also. So according to the KCL on charge, if you will apply the charge in this branch will be, obviously we can write it as incoming charge is equal to outgoing charge. Similar to incoming current is equal to outgoing current, like that. So this will equal to how much? That is 62 coulomb. That is a charge in this branch. Charge in this branch is 62 coulomb. Simple. See, it's very easy to do the calculation. That is the first thing which we have learned, okay, in the circuit theory. And here, so in capacitor, if come, you have to do nothing, you have to follow the same steps. Okay. Now next thing what I told you, what I taught you, if you have remember, the next thing I covered, if suppose I can take the another circuit which is in the same manner, like take one more example. Let us take, there is a capacitor of 1 farad, then there is a battery of 10 volt, correct? Then there is another battery of 12 volt. This is 2 farad. Okay, that is 3 farad. That is suppose you take it as 8 volt, and suppose take this value as again 2 farad. Now here if I ask you how to solve, what is the method I told? You know only one method. What? First take 0. Suppose let me take 0 here. So this is 0, so this will be minus 10, correct? What is this? This will be plus 12. What will be this? This will be plus 8. But can I write the potential here? No, because there is a capacitance. So what is the method? I told you just assume x at this point. This will be also x. So this will be also x, correct? Any doubt? This will be also x. Now here also you have to apply the charge conservation, Q1, Q2 and Q3. Okay, so what is the rule? Q1 plus Q2 plus Q3 is equal to 0. Okay, so if you do this, what is the value you will get? Q is equal to C into V. So 1 into x plus 10. Okay, x minus of minus 10, so x plus 10 into 1 plus what is Q2? X minus 12 into 2. What is Q3? X minus 8 into 2 equal to 0. If you solve this, what you will get? That is 2x, 2x, 4x, 4x plus 1, 5x, correct? Plus 10 minus 24. What is this? Minus 16. So 5x, and this will become how much? That is 4, 6, 10, 2, 1, 3, that is 40. 40 minus 10 is 30, so this is 30. So what is the x value you will get? You will get 6. How much? 6 volt. So if this is 6 volt, can you tell me what is the charges? Now you can calculate the charges also. What is the charge in this branch? That is 16 coulomb. What is the charge in this branch? Can you tell me? That is minus 6 coulomb. And what is the charge in this branch? That is minus 2 coulomb. Correct? Just like, but the charge conservation is not valid. Okay, let me see if did I make any mistake here? Yeah, 2x minus 16 minus 12 to 24 plus 10 . Okay, sorry. Yeah, sorry. Will be how much? Minus 2 minus 4. This will be minus 4, no? This will be minus 4, correct? Because this is minus 6, you will put minus 2, so this will be minus 4 coulomb. This will be in this branch. What is the charge? This value will be a minus 6 minus 12 coulomb. You can see the direction what we have assumed, the charge is coming negative, means it is going like this, not like this, correct? Okay, not like this, it is going like this, and this is giving 16 coulomb. Clear? So this is the another thing. It is same as the KCL which we have learned. Okay, there. So if someone has covered my previous lectures, for them it is very easy. Okay, they have no need to read anything. Just if they know the previous things in current electricity, that is why I used to teach capacitor before, not before the current electricity. Generally people used to teach, but I used to teach after the current electricity. Clear? Any doubt here? Okay, next now the important concept which is very much different, that is series parallel combination. Series parallel combination. If you have first we will see the series combination. Let's see the series combination first. If I see the series combination, okay, so let us start with the series combination first. So basically what I am saying is, suppose I am connecting a capacitors in series, correct? This is what I am doing. I am connecting a capacitors in series. Clear? I am connecting a capacitors in a series. Now my question is that, and suppose there are total n capacitance are there. How many capacitance? N times. Okay. So what is my C net? Okay. See, there is a derivation, but I am not going into the derivation, the same derivation which we have seen in the current electricity. I am just writing what is the direct answer you will get. You will get 1 upon C net is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3 dot plus 1 upon Cn. This is suppose C1, this is C2, this is C3, like that, and this is up to C. This is what you will get. So if suppose I have a two capacitors and they are connected, and suppose this is C1, this is C2, they are connected in series. What is C net in this case? C net will be simply C1 into C2 divided by C1 plus C2. Okay. Second thing, if suppose I connected the two capacitors like this, series C1 and C2, okay, and applied a voltage V. One thing is clear, what is that? Q will be same for every capacitor, because it is a series, the current is same, that means Q is same, because Q is similar to charge. That analogy I have given it in the starting also. So what is in this case, if I ask you what is V1, so V1 will be how much? Q into C1 or C2? This will be C2, remember, C1 plus C2. Now you find the logic, because these logics, everything I have told in the current and electricity. V into C1 upon C1 plus C2. Clear? Like this you can do. And if suppose C1 is equal to C2 is equal to C3 is equal to dot Cn is equal to C. So what is my C net? Then C net will be simply defined as how much? What will be my C net? You can say it is C by N, sir. That we have seen in the last class, in the current and electricity also. So this is about the series combination. See how fast we have covered. Okay. Similarly, we have a parallel combination also. So if someone has covered my current and electricity session, complete circuit theory, it is very easy. Okay. Next thing is series combination. That is series combination is done. Parallel combination. So next topic is, you can say subtopic is parallel combination. Okay, let's talk about it. So in this case, can I ask you what is going to be the same here? Always V, or you can say potential difference is same. Parallel combination, the potential differences same, correct? Any doubt here? So suppose if I have connected a capacitors in parallel, so this is my C1, this is C2, like this, CN like this. Okay, suppose this connections are done. Okay, suppose this is how we have done the connections and they are connected in parallel. So as we know the voltage is same, in this case I am going to tell you the direct formula only. C net is equal to C1 plus C2 plus C3 if you are able to judge, you can say that, sir, the resistance, the capacitance is just opposite of the resistance. Second thing, if my C1 is equal to C2 is equal to C3 is equal to dot 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 is equal to Cn, that is equal to C, and what is my C net? The C net will be equal to something n times of C. Next thing, if suppose I connected two capacitors in parallel. Next point, this is my first point, clear? This is second point. This is the third point. If C1 and suppose this is C2 and they are connected with a voltage of supply V, this is C1 and this is C2. In this case, if suppose I total charge is Q, Q is Q1 plus Q2. Q1 charge in this branch and Q2 is in this branch. So what is Q1? If I ask you, Q1 will be simply written as C1 into Q divided by C1 plus C2, or Q2 will be simply written as, that is C2 into Q divided by C1 plus C2. This is the another thing. This is called as a charge distribution theorem, and this is called as a we have a voltage division rule. Similarly, it's called as a charge division rule. Then we have a voltage like that. You can name it, but there is no such names exist. So these are the series parallel combination. Now in this, if you remember, in the circuit theory we have covered series parallel combination, something like symmetries. We have seen the symmetries also, different types. All these things are valid. Okay, whatever things we have discussed, okay, whatever things we have discussed, all are valid. Then we have discussed the, then we have after that, then we have discussed the different methods of R equivalent calculations in circuit theory. All those methods are applicable here. See, we have seen lot of symmetries and lot of things. Just replace C by and R. Just replace C by R. And if you remember, we have seen the VT stone bridge, correct? So here also we can make a VT stone bridge like this. No issue. We can make like this. Okay. The current in this will be 0, or you can say charge will be 0, while in this upon this and this upon this is same. These things you can do. There is no problem with this. Okay. It is similar what we have done in the current and electricity. So all the rules which we have covered in current and electricity, all those rules are valid in here also. Okay. No need to follow any other rule and nothing. Clear? Any doubt? If you remember, in the current and electricity we have calculated the R equivalent for edge, then phase, then body. What is the edge? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. That is what I think we have calculated. Just what you have to do, you just reverse the answer. Means just reverse it. Means what is going to be the answer? This will become 12 by 7C. Okay, just reverse it like that. So means you have to just reverse the answer whatever you know. Okay, simply you just reverse the answer. Whatever the answer you have got in current and electricity, just replace R by C and reverse the answer. You will get the correct answer. Sometimes people what used to do now, when the question is came to calculate the C equivalent, what people used to do, they used to replace all C by R and then calculate the R equivalent. and after calculating the R equivalent, they just reverse the answer. Simple. They will get the correct answer. Like that you can do here also, because see, that is what I have written here. Because why we are able to do this, because R is equivalent to 1 by C. That is why we are able to get the answer in this manner. Clear? So that is the complete. Here also you can do the same thing. Like suppose I can connect an infinite ladders like this, okay, and infinite times, and I can ask you what is C net. Okay, like this we can ask, no issue. That is not a big problem. This type of things we can do. Okay, that is not a big problem. If you want, I can give you one very good question. You can solve. Okay, in your homework. That is a good question only. The question is question. See, what is the question? Let us see. Suppose I have taken an infinite ladder of the capacitor. This is C, this is 2C, this is C, this is 2C. Like that. Similarly, like this. This is C. This is 2C. Like this, it is going up to infinity. Okay. This whole thing is connected to, suppose this point is point A, this point is point B, this point is A, this point is B. Now this structure is connected with this structure. This structure is connected with this structure. This is 2C. This is C. This is 2C. This is C. Like that, it is going up to infinity. My question is that find C AB. What is C equivalent across AB? That is my question. Clear? I hope you got the point. Like what you have to do, you have to calculate the CAB across this point. Okay, so this is the combination which we have given. I just framed a new question. Okay, basically what we have done, we have connected the two infinite ladders. Okay, we have connected the two infinite ladders. Now you have to calculate the C equivalent. Okay, this is the question. You have to do it and you have to solve and you have to answer me. Clear? Till here, any doubt is there? No doubt? Clear? Okay, so this is about the circuit theory in the capacitor. See, that is only we have to read. Okay, in circuit theory there is nothing new, because if you remember, I have covered all the concept in the current and electricity in very detail. You just take all the example which we have covered and just replace R by C and calculate all the things, no issue. I told you the tricks also, how you can remember the result. Just remember the result in the term of resistance. For the capacitance, just inverse it. You will get the value for the capacitance and replace R by 1 by C. You will get the capacitance. Simple. C net. Clear? So this is the things you can do. Okay. So please note it down. Note this question. Clear? Okay. So we can start the next topic from here. This is called as a let's take it as a different combination of capacitor. Combination, not a series parallel combination. Okay, remember, this is not a series parallel. Different combination of capacitor. You have to give me the answer what I am going to ask you. Okay, suppose someone told me to form a, I need a 10 series capacitor or n series capacitor to be connected together. How much capacitors? Suppose n series capacitors I want to be connected in series. So let you will connect like this, correct or not? This is n series capacitor. So if I ask you how many plates you will require, you will require 2n plates, correct? 2n plates are required. So it will be costly, correct? The fabrication will be little time taking. It will require a large manpower. So it is a disadvantage for us. Fabrication is a disadvantage for us. Fabrication means if we want to make this, because everything is more here. Okay. So what the so its fabrication is difficult. Why the difficult? Because of the more cost. Why the cost is more? Because for making the n capacitor connected in series, we need 2n plates, like twice the number of the plates we required. So its fabrication is difficult. So that's why we have come to the new thing, that is something called as this. This is how it look like. Okay. So if you want to connect n capacitor in the series, how many n capacitor is the series? See, this will form a one capacitor C1, correct? This will form another capacitor C2, like this. This will form some another capacitance Cn. So if I ask you how many plates here we required, see, for if you see, one capacitor is going to share between these two plates, correct? So see, I can say here the number of plates will be how much? N plus 1. N plus 1 plates will be required, correct? You see, for making one capacitor we require 2 plates. Same, one capacitor is one, this thing is getting common, so that means one will be reduced, correct? So plates are required. Okay, so that is why it is more beneficial, because we are able to save our money. Okay, so this is the combination we prefer. This combination in reality, this combination we use in reality. In reality we use this combination, correct? In reality we prefer this combination only. We connect the capacitors by making one plate is common between the two capacitors, correct? Clear? Now let me ask you some questions on this, because there are a lot of questions will come on this. Okay, so let us start with some examples. First, you understand the problem. What is the problem with this design which we are reading earlier, and how to solve that. So this is the solution we have got. Now let us start with one example, then the more things will be clear. Okay, so let us start. Okay, so suppose, let's take one example. My question is very simple. You have to calculate CAB. That is my question. Everywhere in whole, like today, whole everywhere, whenever I will write, you have to simply calculate CAB. That is my question. Clear? So suppose okay, and suppose I have connected this plate with this, and my question is that you have to find, this point is A and B, and you have to find CAB. How will you calculate? How will you solve? Okay, how will you calculate and how will you solve? Just first use your brain, then I will tell you the method. Okay, first use your brain. How will you solve this? How will you calculate the CAB? Basically, now I have given you this combination. Okay, for this combination I have made the circuit here. You have to calculate CAB. Completed? Okay. Sorry. Yeah. So how we will calculate? Simple. It's very simple. What we have learned earlier, that same thing we are going to use. See, let us connect a battery here. Imaginary battery. Imaginary battery. Okay, it's imaginary. So suppose the potential is V. Let's take the potential at point B is 0. If this is B 0, this will be V. correct? If this is V, I don't know about this potential, so let this will be X. So if this is X, these two plates are connected with each other, so this will be also X, correct? Now draw the circuit. Simple. We have 4 point, if you see, sorry, 3 point, V, X and 0, correct? Between X and 0 we have a one capacitor. Between X and V we have another capacitor. Between X and B we have one more capacitor, correct? And finally this is connected to a battery. This point is what? This point is A and this point is B. Can you solve this? Yes. See, these two capacitors are in connected parallel. This is C, this is C, this is C, obviously. So these two capacitors are connected in parallel. So what is the value of these two? These two connected on parallel, so they will become 2C. Their combination will become how much? 2C. Now 2C series with C. So what is my C net? C net will be how much? That is 2 upon 3C. Sorry, 3C. Clear? So like that you have to solve. You have to use your basic geometry, basic circuit theory, what we have learned and what we have covered. Clear? What you have to do? Listen again. First, what you have to do? You have to assume a battery. After assuming a battery, what is the method we are using? That is called potential method. Just start writing the potential. The point where you don't know the potential, just write, assume X, Y, something like that. Then after that, draw the circuit, convert it into a circuit. And how to convert, I told you the method. Then after that you calculate C equivalent. Simple. Clear? Here any doubt? Let's take more examples so that you will become confident enough. Suppose we have a change. Yeah, suppose there are 4 plates and I have connected these 2 plates. Clear? And now this point is A, point is B. The question is remains same until and unless I don't tell you this is CAB. What is the value? Second example, let us take third example. Don't go into the lines, okay? Lines are not straight. Don't say like that. Okay, just assume it is a straight line. Okay, for this you also calculate CAB. Just do the calculation and tell me. I'm drawing things for you, just you tell me what is the CAB. And it remains same. C you have to calculate. Okay, now do the calculation for this and tell me what is CAB. I have given you 3 questions, just do it. Clear? Completed? Okay, so let us see the calculation. Calculation is very easy. What you have to do? So this is a point A. Suppose this is potential V, this is potential 0. Let us take it as X. This will be X. Correct? So we have a point V, 0 and X. between V and 0 we have a one capacitor first. So you just connect a one capacitor between V and 0. Let me connect a one capacitor between V and 0, and between 0 and x we have a one capacitor, correct? Between then V and x we have another capacitor, correct? So now it's simple only. This is C, this is C, this is C. What you have to do? See, these two will be in series, so it is C by 2. C by 2 parallel with C, that is 3C by 2. What is C net? That is 3C by. Similarly here, suppose this potential it V, potential is 0, so this will be also at 0, and this will be also at V, correct? So if you draw the circuit diagram for here, we have a first thing is 0 and V. If you see, all the capacitors are coming between 0 and V. So this is capacitor C, and we have another capacitor that is C, okay, and then we have another capacitor that is also a C. What is my C net in this case? If they are both three are connected in parallel, so this will be 3C, correct? In this case again, this is V, this is 0, so this will be 0, this is X, this will be X. Now we have a point V, 0 and X. What is X and 0? That is a one capacitor C, and between X and 0 we have another capacitor C. Then we have X and V, sorry, 0 and V, we have another capacitor in C, and between V and X we have another capacitor in C. So what is my C net in this case? See, we have a 2C with C, 2C series with C, 2C series with C. What is the value? See, this is 2C which is series with C, so this will become 3C by 2. 3C by 2 plus C, how much? That is 5C by 2. So like that you can calculate the C equivalents. Clear? Just note it down. Completed? Note it down first. Completed? Any doubt? Okay. In the starting of the lecture, I told you something very important. If you are able to, I don't know whether you are able to remember or not, that what is the formula of capacitance? Last formula of capacitance which we have seen, that is, sir, capacitance is nothing Q by C. What is that Q? I told you Q is the defined as charge on the positive plate, or you can say higher potential plate. Q is defined as a charge over the high potential plate or higher potential plate. But you see and try to understand, there is a very important concept I am going to tell you, and most of the students don't know this concept. Okay, what is the concept? Talk here. Yeah, the concept is concept is very important. Star mark. What is the concept? The concept is very simple. See, in capacitance we are writing Q by V, where Q is a charge on the inner surface, where inner surface of the higher potential plate. That is called as a concept. That is a concept which we used. So what I am trying to say basically is, suppose if we have a parallel plate capacitor, and suppose inside surface the charge is 2q is there and 3q is there, correct? And suppose this is minus 2q and this is 3q, like that. And if I ask you what is the capacitance for this, so what you will write? The capacitance will be equal to 2q by, suppose the potential difference is V. That is a capacitance for this. 2q by V, where q is the charge on the positive surface, the higher surface, but it is an inner charge. It is an inner surface. What is the charge on the inner surface? That is 2q. So that is a concept. This is a very important concept. Okay, very important concept. Why I told you this concept? Let me show you one example. Then you will understand the importance of this subset. Very important concept. Because physics is all about concept. If you have read the book of Sri S.C. Verma, you will find that the book name is The Concept of Physics. Okay, because physics is consist of only concepts only. Okay, so this is a very important result which you have to remember, or very important concept which you have to remember. That is, inner charge is nothing but it is a charge on the inner surface. Clear? Now, why I have told you this method, or you can say why I have told you this. Simple. Let me take one example. Example which we have taken. I have taken. If you remember, I have taken one example here. I have taken this example, in which what we have did, we have connected these two surfaces, and this is at potential V AB. Suppose now I am changing the question slightly. Now I am saying I have connected to a potential V. Correct? Now my question is that you have to find the charge on each surface. My question is now changed. Question is charge on each surface. So what is the concept which you have to remember for here? That concept, why I told you, first what step I will do, in spite of knowing anything, just I will write the potential and I will draw the circuit. That is the first step I will do. So I will simply draw the circuit, sir. Sir, between 0 and V, there is a one capacitor, though the two capacitors are in series, sir. Okay. So this is one capacitor, sir. This is one capacitor, and there is a one capacitor like this, sir. You see this point, sir. This point is V, sir. So between V and X, you can say this point is X, sir. And between X and 0, this is X and 0, and this is V, and so this capacitance is C. And suppose this is connected with a voltage V volt. Now my first question will be, okay sir, the voltage across this capacitor I know that is V, so what is the charge on this will be? The charge on this will be become how much? See, initially, if you see and try to understand, initially there is no charge. Initially there will be no charge. When at instant we have applied the magnetic field, there will be no charge. The total charge initial will be 0. So as the charge is conserved, the total charge should be also 0. So this on this surface it should be 0 and it should be 0. Or if you remember the formula, if initial charge is 0 and a final charge is 0, so what is the charge on the outer surface? Q1 plus Q2 by 2. What is Q1? 0. Q2 0 plus 2 plus divided by 2. So that is 0 only. Now the next thing is that if you calculate the capacitance, okay, correct. My question is that, okay, what is the capacitance between X and 0? Between X and 0, you can clear from this picture, sir, X is at higher potential or lower potential? Sir, X is at lower potential. Correct? That is one thing we are very clear. Okay, why 1 minute? Okay, charge will be 0, correct? So between X and 0, we are very sure that is my 0 is my X is at higher potential. That is a very sure. Clear or not? See, because one thing is sure that we don't know like how to give the, see, one thing it's sure that will be which terminal is going to be at higher potential. See, this charge will be 0, this charge will be 0. Correct? Okay, just leave this. First you tell me about this capacitor. See, here the voltage is going to be divided equally because the capacitors are same. So what is the voltage here? That is V by 2. And also here that is V by 2. Correct? Plus minus only. So what is the charge on this? This will be Cv by 2. Because Q is equal to C into V. So Cv by 2, that is at terminal, like inside the charge. This you can see Cv by 2. So this will be minus Cv by 2. And inside the surface it is plus, sorry, inside the surface is plus CV by, correct. Now after that you come to x, v and 0. This is not x now. This is v and 0. Between v and this point is v, remember this. Okay, just let me sorry. Yeah, so this point is v, so what is the charge on this will be, see, v and 0. So obviously this plate will have a positive charge, so if you see this will be, the total charge will be CV. So I can say if the total charge is CV, correct, the total charge will be nothing but CV. So yeah, we can calculate the total charge is, here is Q is equal to CV. Okay, so what is that charge? The charge will be on the higher potential plate with the inner side. So we have a plus minus, then plus, sorry, and the plus CV will be minus CV. Then we have a this surface, for this surface, that is 0 and x. For 0 and x we can say one more thing, this is CV by 2. So which is going to be higher, CV by 2 means it should be connected as the positive plate, correct. So this will be plus CV by 2 and this will be minus CV by 2. Now you calculate the total value, you will get the total charge on these two plates will be 0. Similarly total charge here also 0. So that is how we have to do the calculation. And it's very clear from here also. If you will see, this capacitor will be charged in this manner only. Okay, what about this capacitor? This capacitor will be charged in this manner only. Yeah, what about this capacitor? This capacitor will also get charged in this manner only. Here, so this is how we can calculate the charge also. If it asks, we can do the calculation, but it will be lengthy calculation. Why? Because you have to first make the circuit, then you have to calculate the potential, and then you have to apply this thing. Just remember that whatever the charge you are getting, that is a charge on the inner surface of the plate. Okay, that will be the charge on the inner surface of the plate. Clear? Are you getting my point? Okay, let's take one example so that you will be more confident, and let's take some homework also, that will also going to be help you. What is my basically I'm not, or one more example, let's take one more example. Okay, suppose I'm keeping it little simple for you. Suppose I have connected these two, and suppose this is my point A and this is my point B. Same question is same Q, not Q total flow, Q on every inner surface. What you have to first do, first you will connect the first step will be very clear to you. It's very clear. Okay, this will be potential V. Clear? If it is something like this, this will be V, or this will be 0, so this will be 0. So you can directly say, sir, the two capacitors are connected in parallel, sir. You can directly say, no issue, correct? If these two capacitors are connected in parallel, see, I know how to draw, like I can solve orally also, but for you only I am drawing this. Okay, this potential will be V. So what is the charge on this? The potential will be V, and the charge will be, this will be plus CV, this will be minus CV. Similarly, this will be plus CV, this will be minus CV. Now you can see here, this will be, see what is the charge on this surface will be, the charge will be plus 0. Let me write the charge with some other color, otherwise you will be confused. Why sir is writing 2 times? This is Q, this will be Q, correct? If you see what is the charge, CV and minus CV. This will be plus CV, this will be minus CV, correct? And what is the charge on this? This will be plus CV, this will be minus CV, correct? This is how you will get the charge on each plate. Clear? So this is a one example. Rest, what is your homework? The homework is very simple. Homework is whatever the question we have solved. I'm not writing homework, but I am telling you what you have to do. See, we have done we have done this examples, correct? We have done this examples. I want you to calculate the Q for this configuration, for this configuration, for this configuration. See, we have calculated C equivalent, correct? Now for this configuration, can you calculate Q? Okay, now that will be the good question. Clear? So you have to calculate the Q for this configuration. Any doubt till here? No? So in today's classes, or you can say in today's session, what we have seen basically the circuit theory we have started, and we have seen the some concept, and then we have goes to the different combinations of the plate, and we have seen the different questions and how to calculate the capacitance. Generally in paper they will ask you C equivalent only. This question generally they will ask you C equivalent. This question generally don't come, but yeah, if you want to understand, you can solve. Okay, you can solve this type of question can be framed. I'm not sure whether they will frame or not, but the thing is that yeah, this type of question can be framed. But if you, but it's not a difficult. If you have a concept, if you know the concept, you can easily solve it. That is not a problem. Clear? Till then, if you enjoy this session, please like it, share it, subscribe it, and have a nice day. Thank you.